one of the things that we learned about was called the elastic rebound theory, which is why we have big earthquakes. We know that where the plates touch each other, they stretch out and they bend, and we get stress, and then it snaps, and we see that it comes back together, but not quite perfect. Remember that we measure how strong an earthquake is. We call that the magnitude. We measure the magnitude with a machine called a seismograph. And we can put seismographs, they don't have to be very big. We can move them around places if we want to. You can fit a seismograph in a suitcase. And when we have an earthquake, what we get are waves. But notice, not all the waves look the same. So today I want to show you what the different kinds of earthquake waves are. The first wave that we have is called the P wave. And the P stands for primary. Primary means first, the first wave. So after an earthquake, the first wave that hits the seismograph is this one. And the reason it's first is it's the fastest wave. Why is it the fastest? It goes in one direction. It moves in a straight line, so it always gets there first. It's so fast that it can go through solid, it can go through lakes and rivers and the ocean, water, liquids, and it can even go out into the air. In a big earthquake, you sometimes hear people say, I felt the energy come out of the ground. That's the P wave. And it can even shatter windows. The pressure from the wave can break the glass. So P waves go the farthest and can go through almost anything. Now the next wave that hits is called an S wave, secondary wave, because it's the second wave to hit. Now it goes slower. And if you look in the bottom picture, the reason it goes slower is it's moving in two directions. It's going forward, but it's also going side to side. This one looks like up and down, but really it's moving side to side. And you can see it causes more damage, right? It's much more violent at the surface, but it only goes through solids. This wave cannot go in water. It does not go through the liquid core of the earth. It only goes through solid material because it's slower. It does not have enough energy to go through liquids which are less dense. There is a third type of wave, and we don't always feel them after earthquakes. They're actually the worst kind in terms of damage. They are called the L wave. The L wave, you might remember it's last, it starts with L. It is called a surface wave. Think like the wave on an ocean that goes up and down, but it's also coming towards you. And it's also moving side to side. It's moving in three directions. And so it by far causes the most damage. But it's also the slowest wave because it's moving all over the place. It does not go very far before it runs out of energy. So P waves go the farthest and they're fast. S waves in the middle, and L waves go slow and not very far, but they cause the most damage up and down, side to side. The big earthquake in 1964 in Alaska that shook for several minutes, it had an L wave. And that L wave is what broke those buildings apart and moved them several feet up and down. Very rare to have a big L wave like that. Here you can see the differences again. We see a P wave, if it hits a building, goes kind of straight through the building. The building might jump up and down a little bit. In places that get earthquakes, they design for that. It's got basically big shock absorbers, so it can move up and down. An S wave is the one that's going to cause things to fall down because it's going to wiggle the building side to side, and that's much harder for them to resist. And then the L wave is as crazy as it gets. If you get an L wave, good luck. Okay. That's really all we need to get through today, understanding that earthquakes have different waves and we can measure those different waves with a seismograph. Zoom, take care. I'll see you tomorrow.